Good day to all of you guys. This is my presentation. Work, study, and measurement. Motion study and work design. The number one is basic motion, elements, and work analysis. The second one is principles of motion's economy and work design. And the definition of that, motion study involves the analysis of the basic hand, arm, and body movements of worker as they perform work. Work design involves the methods and motion used to perform a task. This design includes the workplace, layout, and environment. Work design is the design of the work system. 17 third weeks. Transport empty is for reach for an object, grasp an object, transport loaded, move an object, with hand and arm. Number 4, hold an object. And number 5, release load, release control of an object. 6, use, which is to manipulate a tool. And number 7, preposition, position object for next operation. Number 8, position object is defined location. 9, assemble, join two parts. Number 10, disassemble, separate multiple parts that were previously joined. Number 11, search, attempt to find an object using eyes or hand. Third leaks comes from the last name of Frank Gilbreth. Number 12, select. Choose among several objects in a group. Number 13, plan. Decide on an action. 14, inspect. Determine the quality of an object. Number 15, unavoidable delay. Waiting due to factor beyond worker control. And number 16, avoidable delay, worker waiting. Number 17, resting to overcome fatigue. And the classification of third weeks. Effective third weeks, transport empty, grasp, transport loaded, release load, use, assemble, disassemble, and inspect. Use of human body. Number 1 is both hands should be fully utilized. The natural tendency of most people is to use their preferred hand, which is right hand, for right-handed people and left hand for left-handed people to accomplish most of the work. The other hand is relegated to a minor role such as holding the object while prepared hand works on it. This first principle states that both hands should be used as equally as possible. Number 2, the two hands should begin and end their motions at the same time. This principle follows from the first. To implement, it is sometimes necessary to design the method so that the work is evenly divided between the right-hand side and the left-hand side of the workplace. In this case, the division of work should be organized according to the following principle. The number 3, the motion of hand and arm should be symmetrical and simultaneous. This will minimize the amount of hand-eye coordination required by the worker, and since both hands are doing the same movements at the same time, less concentration will be required than if the two hands had performed different and independent motion. Number 4, The work should be designed to emphasize the worker's prepared hand. The prepared hand is faster, stronger, and more practical. If the work to be done cannot be allocated evenly between the two hands, then the method should take the advantage of the worker's best hand. For an example, work unit should enter the workplace on the side of the worker, prepare the hand, and exit the workplace on the opposite side. The reason is the greater hand-eye coordination is required to initially acquire the work unit, so the worker should use the prepare hand for this element. Releasing the work unit at the end of the cycle requires less coordination. The worker's two hands should never be idle at the same time. The work method should be designed to avoid periods when neither hand is working. It may not be possible to completely balance the workload between the right and left hands, but it should be possible to avoid having both hands idle at the same time. The exception of this principle is during rest breaks. The work cycle of a worker machine system may also be an exception. If the work is responsible for monitoring the machine during its automatic cycle, and monitoring involves using the worker's cognitive senses rather than the hands. If machine's monitoring is not required, then internal work elements should be assigned to the worker during the automatic cycle. Number 6. Method should consist of smooth, continuous, curved motion rather than straight motion with sudden changes in direction. It takes less time to move through a sequence of smooth, continuous curved paths than through a sequence of straight paths that are opposite in direction, even though the actual total distance of the curved paths may be longer, since the shorter distance between 2 points is a straight line. The reason why behind this principle is that the straight line path sequence includes start and stop actions, which is acceleration and deceleration, that consume the worker's time and energy. Motions consisting of smooth continuous curves minimize the lost time in starts and stops. Number 7. Use momentum to facilitate tasks. When carpenter strikes a nail with a hammer, they are using momentum, which can be defined as mass time velocity. Imagine trying to apply a static force to press the nail into the wood. Not all work situations provide an opportunity to use momentum, as a carpenter uses a hammer, but if the opportunity is present, use it. The previous principles dealing with smooth continuous curve motion concentrates and beneficial use of momentum to make a task easier. Number 8. Take advantage of gravity. Don't oppose it. Less time and energy are required to move a heavy object from a higher elevation to a lower elevation than to move the object upward. The principle is usually implemented by proper layout and arrangement of the workplace, and so it is often associated with the workplace arrangement principles of motion economy. And the number 9, method should achieve a natural cadence of motions involved. Rhythm refers to motion that have a regular recurrence and flow from one to the next. Basically, the worker learns the rhythm and perform the motion without thinking, much like the natural and instinctive motion pattern that occurs in walking. And the number 10, use lowest classification of hand and arm motion. The 5 classification, which each lower classification, the worker can perform the hand and arm motion more quickly and less effort. Therefore, the work method should be composed of motion at the lowest classification level possible. 11. Minimize eye focus and travel. In work situations where hand-eye coordination is required, the eye are used to direct the action of the hand. Eye focus occurs when the eye must adjust to a change in viewing distance. For example, from 25 inch to 10 inch with little or no change in line of sight. In number 12, the method should be designed to utilize the worker's feet and legs when appropriate. The legs are stronger than the arms, although the feet are not as practical. As the hand, the work method can sometimes be designed to take advantage of the greater strength of the legs, for example, in lifting tasks. And for the workplace arrangement, the number 1 is locate tools and materials in fixed position within the work area. As the saying goes, a place for everything and everything in its place. The worker eventually learns the fixed location, allowing him to reach for the object without wasting time looking and searching. For the number 2, locate tools and materials close to where they are used. If the method requires the worker to move beyond the maximum working area, then the worker must move more than just the arm and hands. This expends additional energy, takes more time, and ultimately contributes to greater worker fatigue. Number 3, locate tools and materials to be consistent with sequence of work elements. Items should be arranged in a logical pattern that matches the sequence of work elements. Those items that are used first in the cycle should be on one side of the work area. The item should be next to the first, and so on. Number 4, use gravity feed bins to deliver small parts and faster. A gravity feed bin is a container that uses gravity to move the item in it to a convenient access point for the worker. For the number 5, use gravity drop chutes, which is channels and tubes. For completely worked units where appropriate, the drop chutes should lead to a container adjacent to the work table. The entrance to the gravity chute should be located near the normal work area, permitting the worker to dispose of the finished work unit quickly and conveniently. They are most appropriate for lightning or lightweight work units that are not fragile. Number 6, provide adequate illumination. The issue of illumination is normally associated with ergonomics. However, illumination has long been known to be an important factor in work design. Illumination is essentially important in visual inspection tasks. For number 7, a proper chair should be provided for the worker. This usually means an adjustable chair that can be fitted to the size of the worker. The adjustments usually include seat height and back height. Both the seat and back are padded. Many adjustable chairs also provide a means of increasing and decreasing the amount of back support, like that. Design of tooling and equipment. Number 1, work holding devices should be designed for the task. A mechanical work holder with a fast-acting clamp permits the work units to be loaded quickly and frees both hands to work on the task productively. Typically, the work holder must be custom designed for the work part process in the task. 2. Hands should be relieved of work elements that can be performed by the feet using foot pedals. Foot pedals control can be provided instead of hand controls to operate certain types of equipment. Sewing machines are example in which foot pedals are used as integral components in the operation of the equipment. As our example suggests, training is often required for the operator to become proficient in the use of the foot pedals. Number 3. Combine multiple functions into one tool where possible. Many of the common hand tools implement this principle, such as head of a claw hammer is designed for both striking and filling the nails. Thirdly, all pencils are designed for both writing and erasing. Less time is usually required to repetition, such as a double function tool, than to put one tool down and pick another one up. 4. Perform multiple operations simultaneously rather than sequentially. A work cycle is usually conceptualized as a sequence of work elements or steps. The steps are performed one after the other by the worker and machine. 5. Where feasible, perform operation on multiple parts simultaneously. This usually applies to cases involving the use of a power tool such as a machine tool. A good example is the drilling of a holes in a printed circuit board or PVC. The PVCs are stacked 3 or 4 thick, and a numerical controlled drill press drills each hole through entire stacks in one feed motion. Number 6. Design equipment controls for operator convenience and or error avoidance. Equipment control includes dials, cranks, levers, switches, push button, and other devices that regulates the operation of the equipment. All of the controls needed by the operator should be located within easy reach so as to minimize the body motion required to access and activate them. For 7, hand tools and portable power tools should be designed for operator comforts and convenience. For example, the tools should have handles or grip that are slightly compressible so that they can be held and used comfortably for the duration of the shift. 8. Mechanize or automate manual operations if economically and technically feasible. Mechanize or automated equipment and tooling that are designed for a specific operation will almost always outperform a worker in terms of speed, repeatability, and accuracy. This results in higher production rates and better quality products. The economic feasibility depends on the quantities to be produced. In general, higher quantities are more likely to justify the investigation and mechanization and automation. Thank you for all your cooperation. Bye-bye.